Hi, so today's video we're going to look at adding and subtracting fractions, and I've got 5 different examples which I'm going to work through with you so we can talk through the process of how to actually add or subtract fractions. Now you'll notice that all of these examples I don't have mixed numbers, I've just got single fractions. I will do another video moving on from this where we look at mixed numbers as well. So to start with, if you look at my first example, keeping it nice and simple, I've got 2/7 plus 3/7, and actually if your question is like this, it's very straightforward. All you have to do is you literally just add together your two numerators. And the reason that you do that, if you think about what fractions actually mean, we have our numerator and denominator, and the denominator tells us how many parts the whole thing has been split up into, and the numerator tells us how many of those parts we're looking at. So if we kind of imagine this as like a pizza or something, and you've got 2/7 of that pizza and 3/7 of the pizza, then all together, if we add those together, we've got 5/7 of a pizza, and that's really how fractions work, and that's why that is the process that we go through. So quite simply, the answer to that is just 5/7. Now that's fine in that particular scenario, and as I say, the reason that works is because these are both 7ths, so the pieces that we're looking at are the same size. If you've got a pizza and you cut it into 7 pieces, those pieces are all the same size, and if you take another pizza and cut that into 7 pieces, then we're looking at the same thing, the same fractions. But when we move on to example 2, we've now got 2/3 and 3/4. So now we're looking at fractions which are different. A third and a quarter are very different things. So if I think about, and I'll try and do this the best that I can, if I think about splitting something into thirds, it might look a bit like that, whereas if I split this into quarters, it looks like that. So the pieces are different sizes, and so we can't compare them, and we certainly can't add them together. We can only add them together or subtract them, the same process, if they are the same denominator, if they're the same size fraction. So we need to use our knowledge of equivalent fractions to be able to convert our fractions first into having the same denominator, and then we can add or subtract them. And the rules for adding and subtracting are exactly the same. The only difference is you do what the sum is telling you to do. So the first step is we must have the same denominator, so we're looking at the same fractions, okay? So we look at our two denominators and we find the lowest common denominator, or actually the lowest common multiple. So we're looking at the lowest number that both of these will go into, so the smallest number in both the 3 and the 4 times table. Now you can either do this by spotting, or if you find it a bit more difficult, take the bigger numbers times table and just go through it in your head until you reach one that the smaller number also goes into. That's the technique that I would use. Now in this case, the answer is actually 12, which happens to be 3 times 4. That's the first time that we get a number that both 3 and 4 go into. So if you go through the 4 times table, you have 4, then 8, and then 12. So 3 does not go into 4, it doesn't go into 8, but it does go into 12. So that's the first time that happens. So now we use our knowledge of equivalent fractions, which I've discussed in a previous video, which you can go back and refresh your memory on if you need to. And you say to yourself, okay, I need to change 2/3 into something over 12, okay? And the way we do this, if you remember from before, is you say, right, what do I multiply 3 by to give me 12? Well, I've multiplied that by 4, and so I do the same with the numerator, and 2 times 4 is 8. We do the same with the other fraction, so we've got here 3/4. What do I multiply 4 by to give me 12? Well, I multiply that by 3. I must do the same to the numerator, I must also multiply that by 3, and 3 times 3 is 9, okay? Now I wouldn't recommend drawing all these lines over it while you're actually trying to do the calculation, because I think it then ends up looking too cluttered, but I've written that on there so that you can see where everything comes from. Ideally you would do that part in your head. You then say to yourself, okay, I've got 8/12 and 9/12, and we've actually reduced it to the same problem that we had in the first example here, and all we do is add those two numerators together. If I've got 8/12 and I've got 9/12, all together I've got 17/12. So it's important to remember that we are adding together only the numerators, because we've gone to all this trouble to make the denominators the same so that we can then just do the calculation in that way. Alright, remember you've got 8/12 of something and 9/12 of something. How much have I got all together? I've got 17/12. Now you can see, I'm hoping that we've now got here a top heavy or improper fraction. Alright, and as I said, later on I'll do some questions where we've got an improper fraction within the question, but if you get one at the end you certainly need to convert it. So say to yourself, how many whole ones will I get out of this? So there are 12 12s in every whole one, so how many 12s go into 17? There's only one. And how many have I got left over? I've got 5 left over, so it's 1 and 5/12, and that's your answer. Okay, now we're going to do each of the rest of these in exactly the same way. Alright, now what I wanted to do, I've picked examples for you to sort of highlight the differences that happen. So in this particular case, when we're looking for the lowest common denominator, here it happened to be multiplying the two denominators together, and indeed the same happens here. Again, if you go through the 8 times table, I would always recommend going through the bigger numbers times table. You have 8, then 16, and then 24, and the first number that 3 also goes into is 24. And so our lowest common denominator, our lowest common multiple, is 24. Same principle again. What do I multiply 8 by to give me 24? I multiply by 3, and so I'd have to do the same to the top. And if I do 7 lots of 3, I get 21. And then the same with this one here. What do I multiply 3 by to give me 24? I multiply by 8. So I must do the same to the numerator. 2 times 8 is 16. And so I end up with 21 over 24, take away 16 over 24. Okay. Now, because this is a subtraction, it doesn't make any difference. We've still done the same process up to this point, and then when we get here, we subtract instead of add. That's the only difference. So 21 over 24, take away 16 24ths. So I do the numerators subtracted each other. So 21 take away 16 is 5. So the answer is 5 over 24. Check your answer to see whether it can be simplified or whether it's a mixed number. If it can't be or it isn't, then you just leave it as it is. Okay, moving on to the last two then. So I'm not going to put the lines in now, because I'm hoping that we should be able to do this without that. But by all means, do stop at each point, have a look at it and see if you can work it out for yourself before you move on. Right, 8/9 plus 2/3. So this time we use the same principle. Go through the bigger numbers times table until you get to a number which the smaller one also goes into. Now the bigger number is 9, and in this case we hit lucky straight away because 3 goes into 9. So using our equivalent fractions, the 9 is our lowest common multiple, our lowest common denominator, and this fraction of 8/9 doesn't change. It remains as 8/9, because we can convert the 2/3 into 9ths, and 2/3 in 9ths becomes 6/9. So 3 times by 3 gives you 9, 2 times by 3 gives you the 6. Okay, so remember to do the same to the numerator as you do to the denominator. We then get 8/9 plus 6/9, which is 14/9. Now that's an improper fraction, top heavy, improper. Numerator is bigger than the denominator, so we need to change it to a mixed number. How many times does 9 go into 14? The answer to that is once. How many are left over? Well, 14 take away 9 is 5. So the answer is 1 5/9. Okay. Right, now the last example here, again, I just wanted to show you another different type. So with these two, both times we had to multiply those two numbers to get our lowest common denominator. In this example, the lowest common denominator happened to be one of the numbers in the question. In this case, we've got 6 and 4, and you might straight away think, oh, the lowest common denominator is going to be 24 because 6 times 4 is 24. But actually, 6 and 4 have got a smaller denominator, which both of them go into, a smaller multiple they both go into. And this is why it's important to go through the bigger numbers times table just to check. So if we go through the 6 times table, we have 6 and then 12, and 4 doesn't go into 6, but it does go into 12. So 12 is our lowest common denominator. This is the smallest number that both 6 and 4 will go into. So you have to be careful with this one. 6 you need to times by 2 to give you 12, so we do the same with the 5, which gives us 10 on the numerator, and 4 you need to times by 3 to give you 12, do the same with the 1, so we get 1 times 3 is 3, so then we get 10 twelfths take away 3 twelfths, and we'll just do the 10 take away the 3, which is 7 twelfths, and that is your answer. Okay, so as I said, I've given you some different examples of different ways of finding the lowest common denominator, or the smallest multiple for both numbers, and we've looked at both adding and subtracting. So hopefully this should be a lot more straightforward now.